Good afternoon, class. Today's class is going to be about something called confidence intervals, which we've seen before in the first semester, but we're going to talk about them again today. So, do I care about this top part? Not really. Okay, so we're going to skip this top part. Okay, so what is a confidence interval? So confidence interval is a value and an error. Okay, so there's a value. So we're going to call this the mean. And then this part is the error. Okay? And confidence interval gives you a range of values where the real mean could be. Okay, so we can call this the fake mean. Okay? What we mean by fake is it's the one we got in the sample, but it doesn't mean it's the one in the population. Okay? So usually here we put the sample mean. Okay, and we're going to estimate, right? So our goal is to estimate the true mean or proportion. That's our goal when we're doing confidence intervals. So how do we do that? We use something. Okay, here we go. So we use our sample, and we use something called the standard error and the margin of error. The standard error is what we used to call the standard deviation. We call it the standard error because we don't know it yet. Okay, so here's our formula. We don't know, so the important part here is we don't know the true population parameter p. We use p hat as the guessed value of p. Okay, so if you draw a distribution, we usually put p hat in the middle, and then we add the error. I guess this one's the plus. So we're adding the error, and here we subtract the error. And with that we get kind of a range. And we say, oh, true mean, probably in here. In this range. Okay? That's the goal of confidence intervals. So it's very similar. We're going to draw normal distributions. We're going to find areas. We're going to calculate stuff. Okay. So here's a formula for standard error. Okay. It's the same as our old standard deviation formula. Right? So I don't like q hat, so I use 1 minus p hat, but that's the same thing. Okay, then we have something called the margin of error. Which contains a value called the critical value, which we'll talk about in a sec. And then notice that this formula is repeated here. Okay, so this is the standard error. Okay, and then the confidence interval itself is going to get built using p hat, so our statistic, our value, right? So it's our sample mean plus or minus our margin of error. That's it. That's what a confidence interval is. Now that might sound confusing, or like, what's the point? It's very abstract right now. Now we have this thing called confidence. So what does 95% confident mean? Let's actually talk about it here. So here's our p hat. This is our value from our sample data, right? And then we have our p hat plus the margin of error over here, and our p hat minus the margin of error here. And then what we're saying is 95% of the time the true proportion is in this range. Okay? So if you look at it visually here on this normal curve, here we go. Every time we're doing a confidence interval, we have our statistic and our range, and notice that most of the ranges hit the actual value, which we don't know. Okay? So we don't know the actual value. Here's our sample values. All the dots here are sample values. 95% of the time, we will contain the real one, and then 5%, right? So 1 out of 20 times, we don't contain the true mean. Okay. So let's talk about critical values and calculate some confidence intervals. So, okay, the assumptions, these are the same as on the quiz for inference. Okay, so in order to use the normal distribution, we have to have an SRS. Our sample size should be less than 10% of everyone. And then we have to have NP hat greater than or equal to 10. And N1 minus P hat greater than or equal to 10. Okay, so that's the same as what we did before. I don't think that's the confusing part here, so I'm not going to dwell too much on this. Don't focus too much on the conditions. We'll fill that in later. Right now, focus on the confidence intervals themselves. Okay. So, alright. We said that the confidence interval is our statistic plus or minus our margin of error. Okay. Now we're going to talk about Z star here. So let's say we had this. Okay. Remember, this is our statistic. This is our margin of error. So we have statistic plus or minus Z star, our mystery Z-score, times margin. It's not an accident that it's a Z, by the way, because it's a Z-score. So here, let's say 90% of this area is in the middle. That means 5% is on the left, 5% is on the right. Okay? So if we do inverse norm, .05 to the left, .05 to the left, we should get this value. And then if we do the same thing to the right, we'll get this other value, right? So that's called our z-star. That's it. It's just the z-score that gives you 5%. 0.645. So it's z-score with 5% of data left or right. Okay, that's called z-star. Okay, for 95%, it'll be similar. So if we have 95% in the middle, we have 2.5% on each side. So we can do the same thing. Inverse norm, 2.5% to the left. Then we get our z-star. Okay, so inverse norm. You could also do like 95% in the middle. That's like another way to do it. Like I'm doing it over here. And we get 1.96. So 1.96. Okay. And then our third one. There's 0.5% this way, 0.5% that way. Okay, so inverse norm. (0.00501). That'll get us our z-score. So 0.005, let's do to the right this time. Let's do to the left. Good. Negative 2.7576. Okay? So, depending on the confidence level, z-star is a different number. That's the big idea here. So, depending on the confidence level, the z-score is a different number. Alright. Okay. Let's jump back to number example 2 actually. Let's go straight to example 3. Okay? So, in 2018, Gallup randomly sampled 1,018 US adults. That's useful information. And found that 31% say they believe that gambling is morally wrong. So our sample said 31% think it's wrong. Okay? So this is n, this is p hat. Okay, let's find 1 minus p hat. 1 minus 0.31. 1 minus p hat is 0.69. That's all the important information that we need. Okay? Find a 90% confidence interval. So let's draw a curve over here just to visualize this. Okay? So suppose 0.31 was our mean, right? Where would 90% of the data be? Okay? What would be 90% if 0.31 was the true mean? Okay? That's because there's 90% here. Okay? So, let's find the z-score. This will be z-star right here. Boom. So, 90% in the middle, it'll be like this one, 5% on each side. So this should be our z-star, but we can calculate it again. Okay, so we do inverse norm. Running out of space here. let's do it. So, inverse norm, 5% to the left. Okay, so Z star is negative 1.64. So this 1.645. Cool. Okay. So there's not a lot of space to write this out. Let's see. Do I have other paper? Well, let me get other paper instead. So we know p hat. We know z star. Okay. Our formula for the confidence interval. Let's actually see if we can keep it up here. All right, here we go. Okay. So our formula. Our confidence interval is p hat plus or minus z star. Okay, and then p hat 1 minus p hat over n. Let's write it as p hat plus or minus z star times the standard error. Okay, which is this p times 1 minus p over n. Okay, so we know z star. That's this number. And we know p. That's this number. So all we need to do is find this. So we're going to do that in green. So standard error, 0.31 times 0.69 all over the number of people, so 1018. Okay, let's see if we can squeeze that in. 0.31, 0.69, 1018. 0.0145. Okay, so that's calculated. So now we have everything we need for the confidence interval. So let's write it out. Confidence interval is p hat, which is 0.31, plus or minus, what was our z star? 1.645 times our standard error. It's the same thing as standard deviation that we've been calculating before. Okay? So 0.31 plus 1.645 times 0.0145. Boom, boom. Let's see. 0.31 plus blah, blah. Great. I don't care about this. Okay. We're going to write our own sentence. So, our rightmost one is 0.334. 0.31 minus 1.645 times 0.0145 is 28.286. Okay. This is an interval. So, this is so tight. Basically, this is 0.286. This side is our other value, 0.334. Okay, that's our 90% region using 0.31 as the middle. Okay, so 90% of the time the real mean should be between these two values. Let's write it in words. So I don't like these pre-made sentences. I think you guys are old enough to write your own sentences. So we're going to write our own sentences. So here's what we say. We are 90% confident okay, and then we use the wording in the question. Why is it not focusing? We're using 90% confident that the true proportion of adults who believe gambling is wrong is between 0.286 and 0.334. If you think about this as percentages, this would be 28.6% and 33.4%. So we think that in reality, between 28 and 33% of adults think that gambling is morally wrong. So that means most adults don't think gambling is morally wrong. We're 90% confident that's true. 90% is like pretty confident. So like you only need 1,000 adults and you're pretty sure that people actually think gambling is okay. Now, if we polled the class, we might get a very similar outcome where you guys don't think gambling is actually that bad. I don't know. But it's not morally wrong or whatever. That could happen. Okay, so back to another example. All right, let's go through this one a little quicker. So, it's a Gallup again. All right, here we go. Okay, so we sample 1,000 adults. 616 reported that they're actively trying to avoid soda. Okay, we'll talk about this. We've done it before, but basically, random check. Is each adult different than each other adult? Yes. 1,009 is less than 10% of the population. Remember, these conditions, check, and then NP hat needs to be bigger than 10, and N1 minus P hat needs to be greater than or equal to 10. Okay? Okay. So, let's find N. So N is right here. And then P hat is just the proportion of people that said yes in the survey. So 616 over 1,009. 616, which is 0.61. Okay? And then 1 minus P hat .61 is 0.39. Okay. Remember our formula for confidence interval is P hat plus or minus our critical score times our standard error. Right now all we have is P hat. So, okay, and then quickly we can do this. This is right here. So 1,009 times 0.61 is greater than 10, and 1,009 times 0.39 is greater than 10. Okay? Don't go overboard with checking the conditions. It's like, they need to be true, but finding the interval itself is something I care a lot more about than whether you know how to check the conditions. Okay? You should know how to check them. It's really just multiplying two things together, so it shouldn't be too bad. Okay, now this video is already dragging on, so let's try to get through this. Okay, here we go. Our standard error is the square root of p times 1 minus p. You guys have done p times 1 minus p over n. Okay? So, boom, square root p 1 minus p, all divided by n. 0.0153. Did I round wrong? Let's just go with it. Okay. Our critical value. Here, 95% confidence. So let's draw our little thing. Boom. Normal distribution. Right? 95%. So, what's our z-score for this? Okay, so we're going to do inverse norm 0.025 to find it. Okay, and it should match what we have at the top. So you'll see in a sec. Inverse norm 0.025 to the left. So z star is 1.96, which is what we found up here. If you want to memorize the one for 95%, please do. So our critical number for 95% confidence is 1.96. We're going to be using that over and over. So let's make sure we have our three things. P hat, check. Z star, check. Standard error, check. Okay? So here we go. Confidence interval is going to be 0.61 plus or minus 1.96 times 0.0153. Okay? And then we're going to make our own sentence. Alright, so 0.61 plus 1.96, 0.153. Boom! So that's the right side of our confidence interval. 0.64. 0.61 minus 1.96. Boom. 0.58. Okay? How do we want to write this? So, really, what I'm thinking about is, right, so here's our p hat. This is what we found, right? And we're saying, if that's 0.64, and that's 0.58, we are 95% confident that the true proportion of US adults who are actively trying to avoid soda is between 58% and 64%. This is actually useful information because that means most Americans are probably trying to avoid drinking soda from our statistical sample. Okay? And if you say this and you say that this is a significant result, you would say, I mean, yeah, this is definitely over half. Would you say over half of Americans are trying to avoid soda? Yeah, because we think it's between 58 and 64. We're 95% confident that it is between 58 and 64, so it's probably more than half. Alright. We are 95% confident that the true proportion of Americans who are trying to avoid soda, who are avoiding Minnesota is between 0.58 and 0.64. So let's do it as a percentage this time. 58% and 64%. Okay, so we only interviewed 1,000 people, and we're 95% confident that the true value is within a 6 percentage point interval. So we don't even have to interview that many people. 1,000 people is doable. Interviewing every US adult is not doable. Okay? We'll talk more about this tomorrow. Good job if you made it all the way through. Yeah, we'll talk more about this tomorrow.